And we will get to factoring those eventually. So some definitions, we already know this, but a quadratic equation is an equation that includes a quadratic expression. So the quadratic expression is that x squared part. So basically today, the big difference that you're going to see, this standard form of a quadratic form is shown. It's right here. Do you see now how we're set equal to 0? Anytime we're finding an x-intercept, that's where our y is 0. So today, instead of seeing equals y, you're going to see equals 0. And that means you're going to find your zeros of this expression. So one method for finding roots, and again, you're going to see the word roots, you're going to see the word zeros, solutions. I play fast and loose with those, sorry. Of a quadratic equation is to find the zeros of a related quadratic. So remember the related functions that we talked about? So basically you take, instead of setting it equal to 0, set equal to y instead so you can graph it. You guys kind of remember doing that with linear equations? It was sort of like, it felt like a waste of time, but I wanted to do it for this purpose. So you can identify the solutions or roots of an equation by finding the x-intercepts of the graph of a related function. So example 1, I'm going to show you where we have one real solution. And in the next section, we're going to talk about why there's only one solution. Because basically what's going to happen is you can have one solution, you can have two solutions, or you can have no solutions. So we want to solve 10 minus x squared equals 4x plus 14 by graphing. So your first step here is to set equal to 0, or I will say put in standard form. So I want all the x squareds, x and numbers on one side equals 0 on the other side. So I'll rewrite this here. We have 10 minus x squared equals 4x plus 14. In order to solve this, first of all, I'm going to switch the order of this negative x squared and the 10, because x squared should come first. So it would be negative x squared plus 10 equals 4x plus 14. I'm going to write out all these steps, but honestly, today you can do this super quick. I know you guys can. So I'll start by subtracting 4x from both sides. There's no actually like x term over here, so I'm not combining it with anything, right? It's just being added to there. I shouldn't say added, but like subtracted. Now I have 3 terms on this side. Then I'll subtract 14 from both sides. So I have negative x squared minus 4x minus 4 equals 0. We're all sniffly today. This is good. All right, so I have this in standard form now. If I tried to graph this with equals 0, right, our calculator has equals y. So I'm going to write this as an explicit step. So write related function. But honestly, I expect that you guys can just do this like in your head. Much like this, you don't need all those steps to do that, or many of you don't. So my related function would be y equals negative x squared minus 4x minus 4. We have now spent many days graphing these. So I'm not going to focus too much on it. I'm going to find my axis of symmetry so that I can center my table, and that's kind of it for me. So our axis of symmetry, as a reminder, maybe I'll put that up here, axis of symmetry is that x equals opposite of b or negative b over 2a. So if I name here my a is negative 1, my b is negative 4, and my c is negative 4. If I want my axis of symmetry, it would just be x equals opposite of b, so negative 4 is what? Positive 4 over 2 times negative 1. Well, that'd just be 4 over negative 2, which is negative 2. Remember, that's the number I'm going to center my table on. Okay, let me show you a cool thing, which probably most of your calculators are now set to this, but this is something I learned yesterday. So on the calculator, and if you have your own calculator, even the older ones do have this. It probably is set this way now, but let me show you anyways. If you hit mode, that's like the display settings for your calculator. If you hit mode and you scroll down to where it says full horizontal graph dash table, just make sure the graph dash table is selected in black. So if it's not selected, so if you have, for example, full is selected, scroll over to graph dash table and then hit enter once that's selected, and that'll just have that selected. Okay, now I'll show you what this is going to do in a second. So then we go to our y equals, clear out anything that's in there, and I'm going to graph this related function. So I'll type in negative, and make sure you do use the negative here, right? Not the minus sign. Negative x squared. Now I use the minus 4x minus 4. Negative x squared minus 4x minus 4. So if the first sign you see is a minus, make sure you use the negative, but the rest can be minuses. All right, now here's the cool thing. You do still have to hit second table, but if you hit second table, it's now going to show you guys your graph and your table at the same time, which is pretty sweet. I believe even the old calculators do that, Natalie. I might have to check. Yours is really old, so we have to check. It works like that? Okay. So the cool thing with this is you can just hit graph and it'll still give you your table. The only thing is if you just hit graph, do you guys see that my cursor is over here? If you just hit graph, that's where your cursor is going to end up. But if you hit second table, then you can scroll through your table like we've been doing. Okay, so that's the difference between hitting second table or just graph. But then we have this table, so we can just go ahead and fill it out. So remember, this is our axis of symmetry. At -2, I see repeats happening. So this is at 0. This is -1. Wait, what am I counting by? That's -3, sorry. -4. That's -1, 0. So at -4, I'm at -4. -3, I'm at -1. -2, I'm at 0. And then it repeats. And I have my table. Literally, that's all the work I need from you guys today. And honestly, if you don't even want to calculate the axis of symmetry, and if you can just see where it's at from this table, I don't care. Just make sure your table is centered correctly. So then I'm going to go ahead and graph this function. So at -2, I'm at 0. At -3, I'm at -1. At -4, I'm at -4. 2, 3, 4. At -1, I'm at -1. And at 0, I'm at -4. I think on your homework today, I still ask you for all the pieces. I still ask you for your axis, symmetry, vertex, all that stuff. But you can see that now all from your graph. So the solution, remember the thing that we're actually looking for, what makes this different from today, is that now I'm finding where my x-intercept is. And there's only one because the vertex of the parabola is sitting on the x-axis. That's where that's going to happen. So either you'll have a parabola that's this way or this way, but you only have one solution. You can also see it from the table. Remember, originally this function was equals 0, meaning your y is 0. So on the table, if you find your y where it's 0, that is your solution for this, that value of x. So to fill this out all the way, we know that our axis of symmetry is at x equals -2. We know that our vertex is from this table, -2, 0. We know our y-intercept right here, also from the table. Y-intercept is 0, -4. The piece we're adding today is your zeros. And you can just list them because there will be multiple for some of them. This one only has one. But our zeros are at -2. Technically, it's x equals -2, but I have it in where you can put x equals -2 or you just put -2. Questions about that? Okay, so I'm adding on today. We're finding zeros as well. Okay, that's with one solution. Let's go ahead and look at where you have two solutions. Two real solutions. So if you guys can think about, like, one solution was where the parabola was literally sitting on the x-axis. Two solutions is where it's going to cut across the x-axis, right? If you have like a U shape, it should cross it twice, right? So this is the most typical one. So I still need to put it in standard form. So put in standard form to start. Some of them will be in standard form, some of them won't be. So this one I'm going to put in standard form. So I'll just rewrite it. 24x minus x squared equals 143. I'll start by switching these around. So I have negative x squared plus 24x equals 143. Subtract 143 from both sides. So I have negative x squared plus 24x minus 143 equals 0. Good thing we don't have to graph our y-intercept because it'd be at negative 143, which is way off our thing. I write my related function. Right, related function. Really, my only difference there is I'm putting y equals instead of 0 equals. And I guess I switched the order a little bit. All right, and now I'm going to graph. So I need to center my table where I see those repeats. So I'm going to center at the axis of symmetry. My A here is -1. My B is 24. I don't need my C, but it's negative 143. So my axis of symmetry would be at x equals negative 24, opposite of B, over 2 times my A, which is -1. So negative 24 divided by -2. So my axis of symmetry is at x equals positive 12. Notice I did give you a different graph here. So that means I'm centering my table at positive 12. So this will be at 11, 10, this will be at 13, 14. All right, so in our calculator, y equals, clear it out. I'm going to type in this equation instead. Again, it starts with that minus, so use the negative for that one. Negative x squared plus 24x minus 143. Hit second table. Now notice my window doesn't really show my parabola here. If you want to change your window, that's this button here. I'm going to show you guys how to do this today, and I'm going to show you how to change your table too. Window is where you change what you're looking at on your axes, okay? So on the window, it's pretty intuitive. X minimum is going to be your X minimum. We can literally just match it to whatever this looks like. So my X minimum here was at -1, so let's make that -1. My X maximum is at 18 because this is counting by 2s. And then this is the only part that's a little weird. It stands for X scale. It's what you're counting by. So what am I counting by on my X axis? 2s. So just make that a 2. On the Y axis, it looks like I go from -2, because I'm counting this little bottom one, up to 8. And what am I counting by on my Y axis? 1. So you don't have to change this. The Y scale is just 1. Don't change these other ones ever. I think these have to do with like resolution and stuff. Don't change those. So then if I hit second table, first of all, now my graph matches that. And I can just scroll through my table. I need to get to x is 12. There it is. And I love you can see the little cursor right with your points. So at 12, my y is 1. At 11, it's 0. At 10, it's -3. Here at 13, it's 0. And at 14, it's at -3. Notice my y-axis doesn't actually go to -3. You guys don't have to make it fit. I just need really 3 points. I need the vertex and the 2 points around it. So if that's off of the scale that I give you, don't worry about graphing those. So at 12, I'm at 1. Be careful here at 11, so that's halfway between 10 and 12, I'm at 0. At 13, I'm at 0. And then, like I said, we really can't graph the 10, -3 because this only goes to -2. So this is enough. I have my graph, and I can see where my zeros are. They're at 11 and 13. I can see that from the table, though, as well. Remember, if you have a 0 in your y, the thing that's next to is your root, or your 0. So on my homework assignment, I would just fill out my axis of symmetry. We did calculate that was x equals 12. My vertex, you can always find it from your table. It's these two numbers together, 12, 1. My y-intercept is not on here, but remember it always comes from your c value if this is in standard form. The y-intercept is at 0, -143. And thankfully we don't have to graph that. And then the last thing that I'm adding on is my zeros. And so you can just list these. I have them put in multiple ways on your homework assignment. So I'm just going to list 11, 13. You could put x equals 11, 13. You could put 13, 11. Doesn't matter. I think I have all the ways to put them in. Questions about 2 solutions. Make sure you're using class time to definitely ask me about how to use your calculator. Now our window is messed up. To reset your window quickly, if you guys hit Zoom and just set this to standard, I believe that is the -10 to 10. So Zoom is like your shortcut preset ones. If you just set it to standard, that's your -10 to 10 counting by 1. So if your window's ever messed up, Zoom standard. Okay, I do want to do one last example, and I'm sorry. It's just because the estimating roots, we can still use our calculator to find them, but you're going to have, I think, 2 or 3 problems on your homework where your axis of symmetry is at 0.5. So I need to show you how to change your table, what it's counting by. So this is the other thing we can do here is that we can estimate roots that fall between an integer value, so between a whole number value. This is already put in standard form for us, so it wants us to solve by graphing. If exact roots cannot be found, estimate the roots to the nearest 10th, then check your calculator. I said nearest 10th. I will always specify, like on the homework, what I want you to round to if it's not obvious, but don't sweat that too much. So the related function for this equation is y equals -x² plus 3x plus 7. And I think you guys can already see why this is like an issue in terms of the axis of symmetry. My a here is -1. My b is 3, and my c is 7. Hopefully you can already see if I'm using that axis of symmetry equation, 3 is not divisible by 2, right? So it's always a problem if I give you an odd number here. So my axis of symmetry would be x equals -3 over 2 times -1. So I get -3 over -2. Does anyone know what is that as a decimal? 1.5. And it is positive. Okay, well, that's a problem. Not a huge problem, but something we haven't talked about before. You can still count by 1s on either side. It doesn't matter. If you want to count by 0.5s, whatever. But I usually just say, okay, less than 1.5 would be 1, 0. More than 1.5 would be 2, 3. If you want to keep counting by 0.5, sure. It just seems like a pain to graph. The issue is, on our calculators, if you clear out your y equals, type in this related function. So that is -x² plus 3x plus 7. if I just hit second table, I can see the graph, and you guys can estimate from the graph, right? I think I can see that my roots are going to be at negative 1.5 and positive 4.5 about, and I'm good with those estimates. You could do that. But if I do want to fill out this table, I'm sort of stuck because I don't have a value of 1.5. And you can see that that repeat happened somewhere in between those two nines, right? So I know this is 9, this is 7, this is 9, this is 7, but I have no idea what my vertex is. So I just showed you how to change your window. Do you guys see in blue above how it says TBL set? That's how you change your table. So it's in the same like button, but it's just the second versus the normal button. So hit second TBL set or second window. And this one's really easy. It's your table start. I just start it usually at a whole number. And then this delta table or triangle TBL, you guys remember, what does that triangle stand for? Change in. It's what you're counting by. So if I need to get to a 0.5, just change it to 0.5. Hit second table. And now I can see that my value at 1.5 was 9.25. All right, so for this graph, I'm still going to have to estimate my roots from the graph anyways. So we might have to go more than 0. Let's find out. So at 0, I'm at 7. Oh, that's right. I also wanted to practice counting by something different on these axes. So let's count by 2s on our y-axis. So I'm going to count by 1s on my x-axis. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. But then I'm going to count by 2s on my y-axis. So negative 2, negative 4, negative 6, negative 8, negative 10. 2, 4, 6, 8, 10. So I did just want to do an ugly problem so that we remember this can still happen. Sorry, I try not to make it happen, but it can. So at x equals 0, we're at 7. So 2, 4, 6, 7. At x equals 1, I'm at 9. At 1.5, so like right here, I'm at 9.25, so like a little bit above that. At 2, I'm at 9. And at 3, I'm back to 7. All right, really not enough points to get me down to my x-axis. So here's where I'm just going to keep graphing points in my table. I look at negative 1, I'm at 3. So I'm not even writing these in my table. I'm just looking at this table. At negative 1, I'm at positive 3. At negative 2, I'm at negative 3. Likewise, at positive 4, I'm at positive 3. 4. And at positive 5, I'm at negative 3. We are really estimating roots here. This is not going to be like totally accurate. We will be factoring to find really accurate roots later on. But I'm just going to estimate based on the graph that I drew. You can also estimate based off of your calculator. Remember how I showed you guys if you just hit graph, your cursor is over here. I'm not going to stop you from using your calculator. If you want to scroll over to where that axis is happening or where that intercept is happening and just give me whatever the exit says, that's fine. So my axis of symmetry that I calculated was x equals 1.5. My vertex from my table is 1.5, 9.25. My y-intercept, I can just pull that from my c value, which is covered up. But let's see. My c was 7, so my y-intercept was 0, 7. Oh, that's right there. And then here's the weird part. My zeros, totally estimated, are going to be at, what did we say, negative 1. Almost looks like 1.6. Let's say negative 1.6, comma, 1, 2, 3, 4.5. Truly, I don't even know what the actual x-intercepts are for this problem. I was just eyeballing it myself as well. That's how much I want you guys to eyeball these if you need to. I think I have them at nice halves for the 2 homework problems that you have this happen. That's as ugly as it gets. Questions about that?